This is chapter 25.6, the trapezoidal rule. This will be probably the last hardest thing that you'll do in calculus. It's not really hard once you get the method down. It's just trying to figure out what goes where. Hopefully you'll be able to follow with my examples and with the examples that are listed on Blackboard. So we start with understanding what we're trying to do. And if you're following in your text on page 758, you can see that it shows a curve, and you're looking for the area under a curve between two values. So you're looking for this area in here under a curve. Usually what we do to find that is we integrate or take the antiderivative. That's what integration is. It's another way of saying we're trying to find the area under the curve. But sometimes, you know, of course, things can't be simple. There are functions which can't be integrated. Therefore, we have to use some harder methods that are called numerical integration. Whenever you hear those two things, you know that you're using a big, long, it's kind of like Newton's method, remember that? It's a big, long process. This isn't quite as bad as Newton's method, but it's fun. Okay, so I'm going over example 2, which is listed in your book on page 759. And our instructions are to approximate, because the trapezoidal rule does not give us an exact answer, it gives us an approximate answer. Approximate the area under the curve from 0 to 1 of the function x squared plus 1 dx by the trapezoidal rule. And n equals 5. So you have to be given some values here. You have to be given a lower limit, an upper limit, a function, and you have to be given an n to be able to do the trapezoidal rule. So step 1, I've broken these into steps. Step 1 is find your h. Now h is going to be, what we're going to do is we're going to take this drawing and we're going to make these trapezoids, and we're going to, of course, then add them all up. But we have to find the area between each increment. And of course, it should make sense to you that the smaller the increments are, the better off your approximation is going to be. But our increments are going to be in terms of h. That's what h tells us. So you're going to start evaluating the function at 0, but then where are we going to first? We're not going to go from 0 to 1 all the way. We're going to start at 0, but how far then is our first trapezoid going to be? So to find h, you take b minus a divided by n. What is b minus a? Well, in your function, this is b and this is a. A is the lower limit, b is the higher limit. Those are called the limits of integration, the two endpoints that you're going to be evaluating. And of course, you would take the value of the integral at 1 and subtract from it the value at 0, and then we'll have this distance in here. So b minus a would be 1 minus 0 over n. And what is n? N is 5. So 5. So we get 1/5, which is, it's easier to work in decimals, 0.2. So h equals, this is important so you know this, h equals 0.2. These are our increments. That's what I call them, increments. Okay, so let's start. First, step 2 is to find y of 0. What is y of 0? It's the function evaluated at a, or the lowest level. So we're going to find f of 0, which would give us, and you just substitute in the function, 0 squared plus 1 gives you 1. Square root of 1 equals 1. So y sub 0 equals 1. Now these are important values that we're going to use. Step 3. Let's find y sub 1. What do you mean by y1 and y0? It's just the increments. Understand that we started with 0, and now we're going to check. So our next endpoint is going to be in 0.2 increments. So next we'll be finding f of, you take what you used before, 0, and add to it the 0.2 increment, which gives us f of 0.2. Let's find that. So now we find the square root of 0.2 squared plus 1. Work that out on your calculator, and you're going to get the square root of 1.04. Whoops. Yeah, that's right. And that is going to equal 1.019839. So y sub 1 equals 1.019839. Okay, great. There's their Newton's method remembrance. Okay, step 3. Let's try step 3 or 4. Are we done yet? How do we know we're not done? Because we only got up to 0.2. We have to go all the way up to 1. So this time we're going to find, our next one would be called y2, which doesn't really matter. The point is you're finding whatever you had before, f 0.2, and you're adding to it 0.2 each time, which equals f of 0.4. And that is equal to the square root of 0.4 squared plus 1, which equals the square root 1.16, and that equals 1.0770330. So y sub 2 equals 1.0770330. Yay. Okay, this is fun, isn't it? Not really. Okay. Step 5. Find find y of 3, which is f of, just keep going. We were up to 0.4 here, so you use the 0.4, and each time you add your h, which is 0.2, which equals f of 0.6, which gives us the square root of 0.6 squared plus 1, which is going to give us y3 is going to equal 1.1661904. There's another value. Okay, let's go to our black. Whoops. Step 6, find our next value. We're up to 0.6. So understand, if we're going by 0.2, we're going to get 0.8, and then we'll have our last value, 1. Because it's important that you know what do you have to keep doing here. So y4 is equal to f of, what do we have here? 0.6 plus our h, 0.2 equals f of 0.8 equals the square root. So you're just substituting in and figuring all of these out. And we get y4 is equal to 1.2806,248. Okay, back to blue because we're starting over. Step 7, find y of 5, which would be f of 0.8 from here plus our h is 0.2. Whoops, let's erase that and write that a little bit nicer. 0.8 plus our h of 0.2 equals f of 1.0, which is, notice, our upper limit of b, so we know we're done. So this will be the square root of 1 squared plus 1, and we get y5 is equal to the square root of 2, or 1.4142136. So now we have all our values that we need. We now have to substitute these values into the final formula. So I have to go to a new page. Let's see what we have. So our formula for the trapezoidal rule looks like this. AT, finding the area with the trapezoidal rule, is approximates, that's not equals, 1 over, whoops, and that's not 1 over h, that should be, let's see here, h over 2. So let me erase this. H over 2 times y0, your first term, plus 2 times y1 plus 2 times y2, and on until you get to 2 times y to the n minus 1 plus y to the n. So you see your first and your last term are not multiplied by 2. So in our form, or in our problem, we had that h was equal to 0.2. We had that y1 was equal to, well, I'm not going to write them all again because that would be a colossal waste of our time. So let's change this and let's just put it into the formula. So I get the area, the trapezoidal rule is equal to 0.2, because that's h, divided by 2, times, what was y0? If you go back to the previous page, y0 was equal to 1, plus 2 times, what was y1? 1.090, here we go again, 1.0198039 plus 2 times y2, which was 1.0770330, plus 2 times y3, which was 1.161904, plus 2 times y4, which is 1.28062448, plus y0, which was a square root of 2, 1.4142136. So in your calculator, you do this whole ridiculous mess, and you actually get that the area, using the trapezoidal rule, it approximates, we don't want to say equals, approximates, in this case, 1.150 rounded up. In your actual computation, you will get 1.148, but they rounded to 1.150. So that is one problem using the trapezoidal rule. Yay! As you can see, I'm not going to do too many of these because they take forever. My video is already up for this one. I may be able to do one more for you and then we'll move on.